Today we're not really learning anything new. We're just going to focus on that difference quotient that we learned yesterday, and we're going to try doing that with some more complex functions. This is the difference quotient. Remember, it's the derivative. It's always a limit. That's how you found the slope of the tangent line, was by treating it like a limit. Now, in class, we had a little inspirational video. You missed out on that. So, one of the bonuses of being in class. Okay, this is what I had done earlier, trying to do what we had done yesterday, where we were taking a quantity and we were squaring it. Now I'm also going to be having a coefficient on it. What's going to happen here, we're going to try to be able to do this in our head futuristically. This is going to be an x squared plus 2xy plus y squared. But I'm also going to have this 5 out here that's going to get distributed. So do you know this part well enough that you could distribute the 5 as you do it? Okay, that's my goal. Here's what I would like you to be able to do, and if you can't, that's okay. I do expect you to know how to square this at least without having to do FOIL. If you can also distribute the 5, that's okay for me. So I'm going to think of that like, all right, this is x squared times the 5 would get you a 5x squared. And then your middle term is going to be x times y and then double it. So 2xy times the 5 is going to be 10xy. And then y squared, but times the 5. We kind of have these ones where you have the quantity squared quite a bit. So if you can do the square it and distribute the 5 at the same time, might save you a little time. Really, you can do this in your notes, but it'd probably be better. I'm just going to be working about 3 problems off of your homework. You can hopefully you already have your homework, or you can just do these on a piece of notebook paper for right now. That would be fun. Now, some hints. Pay attention to the actual limit and what stage you actually evaluate that limit. These different problems, sometimes they ask for you to find the derivative, sometimes they're asking you just to get started on finding the derivative. So pay attention to what it's asking. Your work is going to have to be immaculate. I want to see step-by-step, beautiful work. No sloppy stuff. I won't even look at it. So practice now so that you'll do it nicely on the test. All right, on this first one, this is number 1. If f of x is equal to 3x squared plus 4, so we got a nice quadratic function, which of the following limits will give the derivative? Notice all of your answers. You have not actually found the derivative yet. You haven't evaluated the limit. So you're just getting started in that process. Here we go. You start off and you write the derivative is equal to, and it's going to be a limit, so I expect to see that limit written there. And then we do f of x plus h. That's going to be a 3 And what I'm doing is I'm taking I'm putting x plus h in for x right here. So it's the 3, and then it's the x plus h that I'm going to plug in that's going to be squared. And then it says plus 4. F of x plus h minus f of x. Remember, I'm going to be subtracting the entire function. So it'll change both of those signs. All over h. Now I'm going to clean it up. And I'm going to do, like I said, sometimes as we get into this, I'm going to start expecting you to be able to do some mental math on this algebra. We talked yesterday about how we can square that. You should know what that looks like when you square it. That's just the x squared plus 2xh plus h squared. I'm going to write that, but I'm also going to be distributing the 3 at the same time. Now, I said no, don't skip steps, but there are some algebra steps that I would expect you to maybe be able to do. Now, if you didn't do that, that's okay. I'd rather you err on the side of showing too much work. So it's going to be a 3x squared plus, it's normally 2xh, now it's going to be 6xh. And instead of plus h squared, it's plus 3h squared plus 4 minus 3x squared minus 4 all over h. Now this is one very, very similar to what we actually did in class yesterday. Hopefully this is kind of review for you. And now I'm going to clean it up. I'm not going to be able to do the direct substitution yet. I'm just going to clean up the numerator. Oh look, 3x squared, negative 3x squared, 4, negative 4. This has an h that can reduce. This has an h squared that's going to turn into an h, and that way the denominator goes away. And I'm left with 6x plus 3h. And now I'm ready to do the direct substitution. But remember the question was, which of the following limits would give that derivative? I really want the limit in the answer, so don't go do the direct substitution. Which one of these matches what we have? C. All right, see, it's multiple choice homework tonight. Let's take a peek at number 2. This one asks us to evaluate the limit. In other words, they kind of have already set it all up for us. They've already plugged the f of x plus h business in there, and they've just gotten it started. But they do want us to actually evaluate it, which means plug 0 in for h. Can't do it yet. Look at my answers. These are all going to be actually after the limit gets evaluated. Since it's already set up, I'm ready to go ahead and simplify the numerator so that I can then try to get the h to cancel out. Most of the problems we've done so far have been pretty straightforward, kind of simple polynomial functions. That was kind of to get your feet wet. Today the functions are going to be much messier, and so trying to get you, sometimes you want to do too much of that stuff in your head, and you'll see today that this isn't going to be just stuff we do in our head anymore. I'm going to look at this, and I think I'm going to treat it like we were doing the limits the other day. Remember when we had to rationalize the numerator? That's what I want to do. I want to rationalize the numerator. I'm going to leave the 2 out of it for right now, and I'm just going to multiply by the conjugate of this. And do it in the denominator as well. And I'm multiplying there. Now, the 2 is still going to be out in front. And then I'm going to FOIL the 2 binomials. And I'm going to end up with an x plus h. The outer and the inner will cancel. And then I'm going to have a minus x. And that's all going to be over. The h is out in front. Don't try to distribute it. Just leave it there. We've got this going right here. And now you're ready to go ahead and, so let's come back down here. Now that I've done that, multiplying by the conjugate, let's come down here and get back into what we're finding, which is the derivative. The limit, as h approaches 0, of, and look what's going to happen here, this x and this x are going to cancel, so my numerator is going to be 2h. And my denominator is going to have the h with the square root of x plus h plus the square root of x. Now these h's are actually going to divide away, which is helpful because that h is what was keeping me from doing my direct substitution. Now I'm going to go ahead, since the h's are gone, I'm going to do my direct substitution and take 0, and I'm going to plug it in for the h that's still there. If I'm going to take this 0 and put it in right there, that's going to end up being, oops, sorry. And I've preached this, and then I sat there and did that. When you do the evaluating, when you do the direct substitution, that's when the limit goes away. And I'm actually going to not have to write that limit anymore. It's just going to be a 2 over, I'm going to end up with a square root of x plus square root of x, which is 2 square root of x. The 2's are going to cancel, and I'm going to have 1 over the square root of x. And then I'm looking to see if anything matches, and I think I've got it right there. Sometimes they may end up rationalizing that. They didn't, so just look for when it matches what they have. Let's try number 7 off of your homework. This polynomial function that I'm giving you is a quartic. It's x to the 4th. Okay, let's start doing something a little more interesting. We're going to be finding dy dx. Remember, that's just another notation for finding the derivative. To do a quartic, or anything, a cubic even, we're going to have to use that binomial theorem. So that's the Pascal's triangle. We're going to have to get to the 4th row when we do that, so think about your Pascal's triangle. We're going to use this row right here. This is going to be a little bit longer of a problem, so I'm going to start way over here on the left. I'm going to write little, keep it neat. I'm looking for dy dx, so I can use that notation, dy dx. I could also use the f of x with a little apostrophe thing to do the derivative. Either way, start with that so we know what we're looking for. It's a limit, so make sure you have the limit there as h approaches 0. And then here's what I'm going to have. I'm going to have to take an x plus h and put it in there and take it to the 4th power. X plus h to the 4th power. Wow, think of that. I'm going to go ahead and I'm going to do this one in 2 steps. So I'm going to leave the 2 out in front so we make sure that we do this 4th power thing correctly. And I'm going to start off, and remember that it's an x plus h to the 4th power. That's what we're trying to do. So I'm going to have an x to the 4th. Well, I'm going to use my Pascal number. It's a 1. And then it's an x to the 4th. And then the h is going to be to the 0. Plus. Pascal's number is 4. And then my x is going to work its way down while my h works its way up. Plus, next Pascal number is 6. X is going to be squared, h is going to be squared. Plus 4. X is going to be to the 1st. I didn't need to write that. And then h to the 3rd. Plus, the last one is going to be a 1, h to the 4th. Now, I have my Pascal number stuff figured out, so I'm going to erase that because that's going to be in my way here in a minute. Now, that was just the first part, right? That's just this. Now I have to subtract 3 times the function, and 3 times instead of x, it's x plus h. Okay. Minus 3x minus 3h plus 1. And I'm not done because all I've done is put in the x plus h into the function. Put the x plus h in there, and then I had my plus 1 at the end. Now I have to do minus f of x. That's going to mean it's going to be a minus 2x to the 4th. I'm just going to write it down here. I'll clean it up here in a second. Minus 2x to the 4th plus 3x, and then a minus 1. All of that is my numerator, because remember, it's always all over h. Hopefully you started way over on the left and had a little bit more space to work than I did. But I have to now distribute the 2 through the parentheses, but also try to see if some things might cancel out as I go. I'm going to look at this right here and try to clean this up. I know that my minus 3x and my plus 3x are going to cancel. I want to see you slashing things so that way I know that you caught everything that should have crossed off. So this negative 1 and this positive 1 are going to go away. Well, I might even do this right here, minus 2x to the 4th, because right there I'm going to have a positive 2x to the 4th. That 2 isn't gone. It's just going to have to get distributed through everything. Here we go. Next step. dy dx is equal to, I have not yet evaluated the limit, so let's leave the limit there. And I'm going to distribute the 2. It's going to be, now the 2x to the 4th canceled out, so now I'm going to be left with an 8x to the 3rd h plus 12x squared h squared plus 8x h cubed plus 2h to the 4th. So I've got that all distributed. And I still had left over there a minus 3h Oh, and I guess that's it. Now that's all over the h. Good, so I was able to squeeze that in a little bit better that time. I'm hoping that my h can divide out. If every term has an h, well, I kind of need that to happen. I kind of need every term to have an h because my next step is to get this to divide out. If you have any terms up here that don't have an h, you're in trouble. They should cancel out. So go check your algebra if that happened. I'm basically going to take every one of these h's and reduce their power by 1 when it's dividing. And if there's only one h, it's just going to go away. Next line. I'm still finding the derivative, so I keep this here. I have not yet evaluated the limit, so it stays there. And I have an 8x cubed. That h is going to cancel. Maybe I should cross that, change that to a 1, change that to a 2, change that to a 3, and cross that one off. I'm going to end up with a plus 12x squared h to the first plus 8x h squared plus 2h to the third minus 3. And it's not divided by h because that just went away. Now I'm ready to do my direct substitution because the h went away. And since I'm going to put 0 in for all of my h's, this is where the limit is being evaluated. And as I do that direct substitution, the limit does not get written anymore. And I'm left with 8x cubed. The next three terms are going to turn into 0, and then it's a minus 3. And then I look at all my options, and I hope to see my answer there somewhere. There it is, A. Got it. Definitely longer. Anticipate some of those fun ones. We've done some polynomial functions. We've done some radical functions. Let's look at something that has like a rational, that has some sort of fractions in it. This gets a little bit wormier. Again, I can't emphasize enough to show your work just like I am. You don't get to say, oh, I can do that in my head. I'm not going to work for me. I got to see beautiful, beautiful work. You know who I'm talking to. Let's look at this one. We're going to find the derivative, it says. Then I'm going to start off, and let's write the derivative. Now, again, I'm starting as far left and as far up as I can because I anticipate this taking some space. I'm going to add these two fractions together. And there's different ways to approach this. I'm going to look at it like sometimes you might merge those fractions together to begin with, but some of the problems on your homework that doesn't work real good on. So I'm going to go ahead and work with it separately, and that's probably how you're going to want to do it on your homework. All right. I am going to have to add fractions. Remember, you're going to end up having to have a common denominator. But let's go ahead and do the difference quotient to begin with. The derivative is equal to the limit as h approaches 0 of, now I'm going to put x plus h in for all the x's. It's going to be 1 over x plus h plus 1 over x plus h squared. And then I'm going to have to subtract the function, which means subtract 1 over x and subtract 1 over x squared. Now remember that in this, it's all over h. Gosh, that's going to be really messy, right? So here's what I'm going to suggest. Anytime that you already have fractions, rather than dividing it by h, let's come out here and let's multiply it by 1 over h. That way we don't have fractions caught up inside of other fractions. Now my next step is going to be to go ahead and simplify all of this stuff so that I can try to do something with this h that is keeping me from doing direct substitution. Well, I got a bunch of fractions. I've got to add them. I need a common denominator. It looks like I need an x plus h, but this one says x plus h squared. So I'm going to need an x plus h squared. I'm going to need two of them. Same deal with the x's. I've got this x, but this one says x squared, so I'm going to have an x squared. My common denominator on here is actually going to be x squared and then x plus h squared. That's what I'm going to be shooting for. Let's go get it. Keep the limit. And I look at this first fraction and I say, all right, I've got an x plus h. This is what I need it to be. So it appears I need to multiply by an x squared and multiply by another x plus h. That's going to make your numerator x squared x plus h. Now I'm going to be putting this all over my common denominator, x squared x plus h squared. Rather than writing each one of these individually with that common denominator, I know that this is going to be that next step. Now I'm going to do plus, and I'm going to look at my second fraction and say, all right, this is what I've got, this is what I need, looks like I'm missing the x squared. So the numerator is going to be x squared, and it's going to then be over my common denominator. Minus. This one has an x, this is what it needs, so I need another x, and I need an x plus h squared. So minus x plus h squared. And then the last one has the x squared, it just needs the x plus h squared. And these are all already over that common denominator. On all of that is going to be multiplied by 1 over h. Got to clean that numerator up. Let's get rid of all the parentheses. So the derivative is equal to the limit. I have not evaluated the limit, so the limit stays put. I'm going to distribute my x squared. It's x cubed plus x squared h plus x squared. And now this is the tricky term because I need to square this binomial and then take the negative x and distribute it. So let's do this one a little bit slower. To square this binomial, you'll have x squared, but then I have to take it times negative x. That'll be negative x cubed. And then I would have 2xh times negative x. That'd be negative 2x squared h. And then I have h squared, but times the negative x. Now I have this term, and I have to subtract this binomial squared. So normally it would be x squared, but now it's going to be minus x squared. The second one would normally be 2xh, but now it's going to be minus 2xh. And then instead of plus h squared, it's going to be minus h squared. And this is now all over the common denominator, x squared, x plus h squared. I'm going to leave that alone. I'm not going to multiply that out, and you'll kind of see why here in a minute. And remember that this is all times 1 over h. Holy moly, let's see if something will cross off. Here I have an x cubed and a negative x cubed. I have an x squared and a negative x squared. I don't see anything else that is going to cancel. So now I'm ready to take this h here, and hopefully every term has an h to reduce by. Yes, 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 yes. Okay, let's go ahead and reduce by 1 power on each of those. That's going to make this h go away. It's going to make this h go away. It's going to make this h squared turn into h to the first. It's going to make this h go away. And this h squared will be to the first. And at that point then, my h goes away. Let's see what's left. Haven't plugged 0 in yet, so let's keep that. Don't be too anxious to do too much all in one step, because I have to be able to follow what you've done. I did FOIL, and then I have a lot of slashes in here, so that was plenty to put into one step. Now I'm going to have the x squared still sitting there. I I have a minus 2x squared. Oh, okay, so that's going to actually be able to combine. Could we go ahead and combine those? Those are like terms. X squared minus 2x squared. I didn't notice that I could have combined those earlier. That's just going to be a minus x squared. Okay, so that takes care of this term. It takes care of this term. Now I have a minus xh. And I have a minus 2x. And a minus h. And that's all over the common denominator, x squared, x plus h squared. Whew. Let's do the direct substitution now. We're going to actually evaluate the limit, so on our next step we don't have to write it. We're going to actually do the plug 0 in for here. Well, that term's going to go away. Plug 0 in there, that term will go away. Plug 0 here, and I'm going to have x plus 0, which is just x squared. Okay, here we go. F of x is equal to, evaluating the limit, so I'm going to have a negative x squared. This goes away. This will go away. I just have a minus 2x all over. And again, remember, if I put 0 here, this becomes just x squared times x squared is x to the 4th. And then I go look at all my answers, and I think, none of those match. So is it this? Or do you see that these are all written differently than mine is written? They've actually separated this into two fractions. We can do that. Let's separate this. Basically, this needs to be divided by x to the 4th, and this needs to be divided by x to the 4th. All right, I'm out of room vertically, so if I'm going to move horizontally, I like to put an arrow. And I'm going to have a negative x squared over x to the 4th minus 2x over x to the 4th. And now I can see I can actually do some reducing. An x squared over an x to the 4th is going to be a negative 1 over x squared. And then I'm going to have a minus 2, and the x to the 4th will reduce, and I get this. Now, does that match anything? Right there. There it is. We've got our answer. Okay, this is the derivative. There's your answer. You have to be really neat in your work so that you don't, it's really easy to mess up the slashing to, this particular problem I went and did on paper first before I did it here to make sure that I didn't forget some of those steps for you. You're going to have to be careful as you do these as well. But they're kind of fun once you get going on them. If you like that algebra stuff, and I know you do. Good luck.